speaking about the rates of reactions. So, welcome to our presentation today. As we delve into this fascinating topic, we will explore the factors that affect reaction rates, the collision theory behind chemical reactions, and how to measure these rates in various ways. But first, let us consider why rates of chemical reactions are so crucial. Chemical reactions are all around us, from the rusting of iron to the combustion of gasoline in our cars. Understanding the rates at which reactions occur can help us develop new technologies, improve industrial processes, and even save lives. For example, knowing the rate at which a drug is metabolized in the body can help doctors determine the correct dosage for a patient. By studying rates of chemical reactions, we gain a deeper understanding of the world around us and make meaningful contributions to society. So, what factors affect rates of reactions? Temperature is a key factor affecting reaction rates. As temperature increases, so does the rate of the reaction. This is because the increased energy causes more collisions between particles, leading to a higher likelihood of successful collisions resulting in a reaction. Concentration is another important factor. When the concentration of reactants is high, there are more particles in a given volume, increasing the frequency of collisions and therefore the rate of the reaction. Conversely, when the concentration is low, there are fewer collisions and the rate of reaction decreases. Surface area also plays a role in reaction rates. When a solid reactant is broken into smaller pieces or powdered, its surface area increases, exposing more of the reactant to other reactants and increasing the frequency of collisions and the rate of the reaction. Catalysts are substances that increase the rate of reaction without being consumed themselves. They work by providing an alternative reaction pathway with a lower activation energy, making it easier for reactants to collide and react. For example, enzymes are biological catalysts that speed up chemical reactions in living organisms. Now, we spoke a lot about collisions and successful collisions, but what does that actually mean? Collision theory is a fundamental concept in understanding the rates of chemical reactions. It states that for a reaction to occur, particles must collide with each other with sufficient energy and proper orientation. The energy required for a successful collision is known as activation energy. By increasing the temperature or concentration of reactants, we increase the likelihood of successful collisions and therefore increase the rate of the reaction. Additionally, catalysts can lower the activation energy required for a reaction to occur, further increasing the rate. A reaction mechanism refers to the series of steps that occur during a chemical reaction. Each step involves the breaking and formation of bonds between atoms and molecules. The rate of a chemical reaction is determined by the slowest step in the mechanism, known as the rate determining step. Understanding the reaction mechanism allows us to predict the rates of the reaction and design ways to speed it up. One example of a reaction mechanism is the oxidation of ethanol to acetic acid. This reaction occurs in several steps, with the rate determining step involving the formation of a carbon-oxygen bond. Another example is the decomposition of hydrogen peroxide into water and oxygen, which occurs through a series of intermediate steps involving the formation of free radicals. There are several methods of measuring the rates of chemical reaction, including monitoring changes in concentration over time and measuring the production of a gas. One common method is to use a spectrophotometer to measure changes in color as the reaction progresses. This can provide a precise measurement of the rate of the reaction. Another method involves the measuring the amount of product produced over time. For example, if a gas is produced during the reaction, the volume of gas produced can be measured at different time intervals to determine the rate of the reaction. This method is commonly used in industrial settings to monitor the efficiency of chemical processes. In conclusion, understanding the rates of chemical reactions is crucial for a variety of reasons. By knowing how to control and manipulate reaction rates, we can improve industrial processes, develop new medicines, and even reduce environmental pollution. We have discussed the factors that affect reaction rates, including temperature, concentration, surface area, and catalysts. We also explored the collision theory of chemical reactions and how it relates to reaction rates. Additionally, we described the steps involved in a chemical reaction and how they contribute to the overall rate of the reaction. Finally, we learn how to measure the reaction the rates of the chemical reaction using different methods. As you leave this presentation, I urge you to consider the impact of understanding rates of chemical reactions. Whether you're a scientist, engineer, or simply a curious learner, there is always more to discover and explore in the fascinating field of chemistry. I hope you guys enjoyed today's lesson.